Hey there, I'm Patrick Seyfert, Applications Engineer here at Digitized Designs, and welcome to the February edition of Webinar Wednesday. I've been looking forward to this one personally, as I'm going to get to show off one of my favorite scanners, as well as one of the more unique among our lineup, the Artec Ray. The Ray is a long-range 3D laser scanner that uses LiDAR to produce high-resolution point cloud data. It makes it ideal for scanning large objects or environments, even those far away or otherwise hard to reach, up to a range of 110 meters or about 360 feet. First thing you might have noticed about this scanner in comparison to most of our lineup is it's not handheld, but rather tripod mounted. On board, we've got two buttons, two texture cameras, and this rotating mirror assembly here, which is where that laser originates from. So when the Ray takes a scan, it stays in one position, rotates this mirror around its axis, like so, and the entire scanner body around this fixed base. And then that enables it to collect data in a 360 by 270 degree field of view around the scanner. It's 360 degrees horizontally around this axis, and then 270 degrees vertically around this axis here, with that 90-degree gap in that axis centered around the straight down, so kind of around a cone around this tripod here, if you will. The Ray's resolution is specified a little differently compared to other scanners just because of the nature of the technology. The scan resolution in this case is measured in point density, and that's specified in points per degree. And you can set that anywhere from 20 up to 80 points per degree. And in advanced mode, you can actually split that into vertical and horizontal if the need arises. So that being angularly based means that the resolution of that final point cloud or mesh is going to depend on how far away the object is from the scanner that you're scanning, or even individual parts of it. So a wall that's really far away is going to get less resolution than an object that's up close at the same resolution setting. But at close range, just for reference, you can achieve mesh resolutions of about 0.5 millimeter, similar to what you could expect out of the scans resulting from the Artec Leo or the Artec Eva. The Ray can be plugged into AC power and controlled by directly by the PC with the included USB and power cables. And then you can scan directly into Artec Studio that way, or you can use it wirelessly, power coming from a removable battery inserted as such, and then control happening either through a tablet or smartphone. Usually we use an iPad. With the Artec Remote app available both for Android and iOS. Also possible is autonomous mode, where scanning looks like just putting the battery in, setting the device where you want to take a scan from, and pressing a button, and beginning a full 360 scan that way. Those two wireless modes, both controlling with the tablet or the smartphone, as well as autonomous mode, store all your scan data on board the device on a micro SD card inserted in here near the battery for later import into Artec Studio. There are two major scanning methods with the Ray: large object scanning and environment scanning. Large object scanning can be thought of as taking scans from multiple positions around an object, usually at a higher point density or resolution, intending to keep just small portions of each of those scans, the ones containing that object or any target you're using for alignment. A good example of this would be vehicle scanning. You can imagine anything from the size of a small motorcycle or car, all the way up to really big stuff, construction equipment, boats, or airplanes. Environment scanning is done by taking multiple scans at various positions inside of something like a large vehicle or a building, intending on keeping that full field of view of each scan. I've got examples of both of these methods I'll be showing you here in just a moment, as well as what the control interface looks like, both in Artec Studio, controlling the device with a PC, as well as on the Artec Remote app, controlling the device with a tablet or a smartphone. Okay, so now we're over here in Artec Studio. I've got the Ray hooked up by USB. To begin scanning, we're going to go into the Scan tab and just click Scan with Artec Ray. First thing I'm going to do is take a preview. It's just going to take a couple of minutes here. We'll fast forward through that. Now that preview is completed, we've got this black and white image of what the scanner can see all the way around. And we've got our controls here. In Artec Studio, you have the highest degree of control over how your scan. Starting here with your point density, scalable down anywhere from 20 all the way up to 80. Default, it's at 40. Unique to Artec Studio, you can control the range at which this scanner is going to capture data. So if we hover our mouse over this grayscale image at each of these points, we can get an idea of what range we're looking at. So this far wall we're looking at here is about 11 meters away. Looking for the furthest thing I can find. It looks like nothing's really much further than 12. So I could crank this down all the way from 110 down to 12 or 13, put it at 15. And that'll keep us from getting any extraneous data, noise. If we were able to see out into the hallway or out one of these windows, it would keep us from capturing extra, more data than we need. Also here's detection of targets automatically. These checkerboard targets, you can see some of those dotted around our office here. There's one right there, a couple on that back wall, and then spheres. These here might actually show up as spherical targets. We'll see here in a minute. Also under advanced, we have sounds. That's going to turn this the beeping on and off. If you leave this checked, the ray will beep to let you know that it's continuing to scan, and it'll stop when it's finished. Texture was whether we're going to capture those texture images that those two onboard cameras are capable of getting at the beginning of the scan. It just takes a few extra minutes. And then tilt correction here for if we're scanning way out of level. Down here in the bottom right, we're getting an estimate based on these settings of the expected size of the scan, as well as how long it's going to take. You can see if we turn this resolution down, that goes down. We turn this resolution up, it goes up. When you have this basic and advanced toggled on and off, advanced gives you access to these miscellaneous settings here, as well as changes the density to being 1 slider to 2, and lets you control the horizontal and vertical point densities independently. These controls appear at the top. Let us, instead of capturing a full 360, this entire field of view, if we've only got part of this scan that we want to be able to capture, we can grab this add to scan tool here and say I wanted to just capture myself. I can draw a rectangle around that, and so far we'll only have captured, this scan will only capture that area. But I can add on, I can keep adding more if I wanted to get the back of this computer, this chair over here. If I grab too much, I can grab the opposite of that tool and take stuff away. If I just want to grab everything, there's a tool to do that, or to deselect everything. I want to do that as well. If you turn everything off and you click scan, that's just going to do a full 360. You see on this, this is kind of the maximum amount of time you could expect one of these scans to take on max resolution. Full 360 takes about 37 minutes. Compare that to just this little wedge at 20, really fast, 1 minute. So when you have all this dialed in the way you want, you just click scan, and you'll see the ray will start beeping. If you have this sounds checkbox checked, it'll take its scan, and then it will deposit that file into Artec Studio, where you can start manipulating it in the workspace. What we're seeing here, this is what the Artec Remote app looks like running on an iPad Pro. This is just your first page, just how to connect to the Ray. All we've done before this is the iPad's connected to the Ray's Wi-Fi network. And we're going to wait for the Ray. Once it's powered on and it beeps, you can connect to that Wi-Fi network and click this Connect to Ray button here, and we will connect. So this is what it looks like when you've connected successfully. This is the basic just interface. We've got this advanced button right here to open up some more settings. But right now, if we wanted to just scan as quickly as possible, we've got resolution and a scan 360 button. And we could get scanning as quickly as setting this resolution and clicking that button. So opening up these advanced settings, We're also able to control the sensitivity. It's got 3 settings: normal, low, and high. High sensitivity you'll want to use for things like dark and shiny, things that typically give a 3D scanner trouble scanning. And low sensitivity in cases where scan surfaces are ideal, matte, white, bright colors, easy to scan stuff where you want to minimize noise. But typically normal is a good starting point. In addition, that resolution slider is broken up into horizontal and vertical, both still maximum of 80 lines and points per degree, minimum of 20, but you can set those independently if you'd like to in advanced mode. Lastly, at the bottom here, we've got these sound and texture switches. Sounds turns the ray beeping on and off. It'll beep while scanning, just to tell you that it's scanning. You can turn that off here if you like. And texture, whether to take the texture photos at the beginning of the scan that can be used to color that point cloud and resulting mesh. So the next thing we're going to do is hit this preview button. It's going to start the ray spinning up, and it'll take a really quick 360 scan to populate that select area box we saw up at the top, which will then let us select a sub area as an alternative to scanning the full 360. Something interesting to note as we're watching this preview fill in here, as you see, it's kind of filling in 2 areas at once. It's taking 2 vertical lines simultaneously as that scanner goes around. So what that's doing is the ray is actually capturing data out of the front and the back with each rotation of the mirror. So instead of the full 360, you can kind of consider it a 180, but it's capturing out the front and the back, so it still gets all the way around. That's happening in the full regular scan 360 mode as well as this preview mode. So once this preview is completed, it'll pop us back to that first control screen, but now we'll see that select area box up at the top here has been filled in with that grayscale image, and we can click into that and use that to select sub areas of the full field of view that we'd want to capture instead of the full 360. Got just a box select highlighted up at the top here. This circle is a lasso. We've also got remove versions of both of those if you select too much or you want to clean this area up. And also we've got a select all tool here and a select none. So once we're finished, we hit the back button, go back to the main control page, or come back into the select area mode, grab what we'd like to scan quickly here. Same thing applies as within Artec Studio, though it doesn't give you a preview of how long it's expected to take. A full 360 is going to take a lot longer than a small wedge. So the scan at default resolution 40 by 40. In that small area, we can expect that to take probably just a few minutes, as opposed to the full 360 at this time would take 20 to 30. So again, in Artec Studio, but what I've got pulled up this time is a completed ray scanning project. In this case, this is a scan of our office suite here with 9 different scanning positions. I've got all the raw data and the intermediate fusions and the final meshes. Just thought I'd go through this as an example of a full project workflow. So you can see we've got important detail here, and this display menu, usually back face, is set to show by default. But so this is kind of looking at the inside out of these exterior walls. We'll flip it to cull, so any of those normals that are facing away from us don't get displayed by the camera, so we can see into the interior of the building where we're concerned about the scan. So it's got one of these raw scan frames displayed right here. I'll turn on these first 6. And these, I've got their registration locked. I left them registered. I actually unregistered these 3 so I can show you what the registration process looks like. We'll go to the top view, zoom back in. Actually, if we turn these on one by one, you can kind of get an idea of where these were positioned throughout the office. So this one was right here where this circle is, where that gap in the field of view is pointed down at the ground. That one's right there. And you can usually you can see a big circle as we'll go through these. This one was right here. You can usually tell where the ray was positioned based on that circle, and any of these like shadows you'll see throughout the scan. Alternatively, you can right click on the scan and hit go to scanner viewpoint. That'll put your center of rotation at where the ray was placed for that scan. It's kind of neat. You can then rotate your view around. Usually takes a second to get oriented, but then you can kind of look around the space from the point of view of the scanner. In this case, you do have to have perspective view turned on here in the view menu. So we'll actually go back to orthogonal, go back up to that top view. I'll cycle through these one by one so you can just get an idea of where they're placed, kind of just the evenly spaced throughout the room. We did this corner, this middle point here, one right there, and then an even grid space throughout the rest of the office. So I'll turn these all back on. These are the registered ones. We'll turn these not unregistered yet, but I will unregister them just to show you. So that's what they came in looking like straight off of the ray. To register those, we'll just go into Tools, Global Registration. In this case, make sure this preset set to Artec Ray. And then targets is all we want to use. We had plenty of targets, about 10 or 15 of these, about 15 of these checkerboard targets evenly spaced throughout the office. I'll show you in one of the scans in just a second. But if you've got at least 5 overlapping targets in each scan, this should work. It's all you need for alignment is those targets. And you see, we click apply and those snap together really quickly. So at this point, these are all aligned. We could do just one of the regular fusion algorithms here in Artec Studio for ray fusion. These default to 5mm resolution. I can tell you from experience, these are really large. This is a really large set of scan data. This is 9 full 360s with no extra data being trimmed. We do have a lot of noise, exterior things where, you know, the ray caught some points out of a window or out in the hallway or something that we would want to clear out if we were going to fuse these like this. Or either way, since these fusion algorithms are volume based, it's really critical to, even if there's just a few points way out here in space, it's based on this bounding box around this data. So if we use the eraser tool, grab a rectangle here, do an invert select to delete all this extra noise, which I can actually do. That's really important for making that fusion run in a reasonable amount of time. So I'll go back to top, I'll zoom back in, rectangle, lasso, either one, and we'll grab just where we're concerned with this data here. We'll invert that and erase everything else. Also turn 90 degrees just to make sure there's no noise hanging out in the vertical direction either way. We'll hit erase. So now we got rid of all that noise way out here in space. So again, going back to the Tools tab, we could fuse these normally with the Sharp Fusion algorithm, but that'll take a really long time compared to this ray scan triangulation. It's kind of a special fusion algorithm we have specifically for ray data. Since it's just built, the point clouds organized a little bit differently, and just by nature of the way it's collected, it's they're a little more sparsely placed than data from one of the other Artec scanners, but each point is a lot cleaner and a lot more what's the word, trustworthy, if you will. And the ray scan triangulation method of fusion kind of takes advantage of that. It's a really efficient way to mesh this large of a set of data. You can only mesh one scan into one fusion this way, but you can run all 9 of these simultaneously. It just produces like what you see over here on the right. We have 9 raw scans, and if I hit ray scan triangulation, right now, it would make 9 more fusions. So that's what we've done here with these settings to make these 9 here. I'll display these. And so this is kind of an intermediate step. We've turned those point clouds into mesh data, but each one on its own. These are a little bit heavier. They take a little bit longer to display. But yeah, you can see these are cleaned up a little bit, especially big flat areas where they're supposed to be connected together. Look a little bit cleaner than the raw data. But we're still one step away from a finished scan for combining all 9 of these together. So now that we've got these are at least better organized and more suitable for fusing together than the raw data. So we can take these 9 now and then run a sharp fusion on them. Typically the same resolution or a little larger than you would what the ray scan triangulation settings were. So we can see here this desired edge length is kind of a similar parameter. We had this set at 5 for all of these. So I've got actually 3 here. This one, Sharp Fusion 1, was set at 10 millimeters, so we'll lose a little detail, but this ran a lot faster if you're just trying to get to something quickly to see what you've scanned so far. We'll look at this ferro arm, for example. This is set at 10 millimeter and then 5 millimeter. You can see that detail comes in a little bit sharper on that one. So I'll just zoom in on this sharp fusion here. This was 5 millimeter, again, matching the resolution which those ray scan triangulations were set. And I'll just pan around the space to give you a look at the data real quick here. Turn perspective view back on just to give you a better idea. Looks a little more natural to look at. I can actually see some of us standing at desks there. We were moving around a little during the scans that happened to catch us. That's why some things there look weird. Like all of this stuff here is just different positions of me sitting at my desk or standing nearby or moving. Same with Bo there. His head moved around a little bit while he was scanning or being scanned from multiple places. So looks a little interesting, but zoom in on this chair to give you an idea of the detail. We have a sample scan of this chair scanned with all various other scanners, the Artec Eva and the Leo. You can compare to this, that at least this didn't get it from all the way around, but the areas it did cover looks similar to those 0.5 millimeter fusions of this same chair from those other scanners. Something I should mention is that the sharp fusion was run. Ray scan triangulation does not do any hole filling, but the sharp fusion was run with a little bit of hole filling, fill hole by radius, with 150 millimeters, I believe it was. So any hole smaller than about 6 inches got tried to be filled in by the algorithms. Gets what happens with stuff like this, the back of these monitors here, that didn't get captured very well by any of these 9 scans. That hole filling tends to look like that. Though in some places you can tell where there were holes in the data in the floor that got filled in really nicely. I'll make sure to turn this around this way too and get a good look at the ceiling, because when we're looking at it from the top, those faces are all cold, so you can't tell. But look at this from the bottom even. That captured everything all the way around, even this AC ducting here, except for the very top, since the ray just doesn't have a sight of those points. But from the bottom here, that's more than enough if you needed to pull data from this to do anything with engineering wise or building measurement wise. More than enough of that cylinder there to capture the axis and the size of that tubing and everything. Same with these electrical conduit on the wall and everything like that. So we've got pulled up now that we're looking at is a scan of a boat done with the Ray. This was done with 6 scans evenly distributed around the boat. So right now we're looking at the finished fusion. Go back to the raw data all aligned together. You can see we've got 1, 2, 3, 4, 5, 6 scans here. So this is after they've all been trimmed up with the eraser tool and aligned together. And an example of what a raw scan coming off of the Ray would look like is this guy here. It's just a copy of one of those 6 that was left unmodified. You can see the circle here. This is where the Ray was placed for this particular scan, capturing this wedge that contains the boat. When scanning large objects like this, typically you have the resolution turned up higher, and to minimize your scan times and the weight of that raw data will capture just this wedge of the field of view containing the object instead of the full 360 all the way around. We still get some extraneous data that way, anywhere behind the boat that was getting part of this house here. Oops. We have all these trees and leaves and all the stuff behind the scanner that it can see, or behind the boat. The scanner can see all the way up to its full range of 110 meters. So really easy to clean up. Editor tool, eraser. Just grab a lasso, grab the boat and the floor or ground. That's what it's called when you're outside, around it, and hit inverse and erase, and that cleans up all that extraneous data. So this one now would be ready to combine with, go through each of the 6 raw scans and delete that extraneous data, run them all through the alignment, and then we'd end up with this here, 6 of those all put together. So once those are all cleaned up and aligned, they'll each get Ray scan triangulated individually. You can run that all at the same time. That's down here in the post-processing section of the Tools tab. That kind of is an intermediate fusion step. Can only be run on one scan at a time, but it's kind of a fusion optimized specifically for Ray data. So that'll make these 6. These are fusions at this point, but they're all still separate. And then we'll fuse all of those together with a standard sharp fusion, resulting in this, the final scan. So this is one mesh containing all that data. So I'll just spin this around here to look at real quick. In this case, we were just specifically trying to get this outside profile of the boat. The Ray was a little too low in each position to capture much interior, but we could have cranked there's a elevation on the tripod you can crank up, and that would let the Ray see into this area a little better and capture some of that. I'll zoom in a little so we can see some of the detail here. There was a little bit of prep done on this as well. This rail here was a shiny mirror finish chrome, so we did have to tape up some of that with some painter's tape to get that to pick up. This area here was all polished metal as well. That's why it came in a little messy. If we didn't need that for our purposes for this scan, but if we needed to, we could have sprayed that with some ASUB or some other dulling spray and been able to capture that a lot better. Same with a couple of these areas down here. That's just where the Ray was positioned. It couldn't quite see there. We could have grabbed a couple extra scans, one from maybe the ground right here that could have seen up in that area a little better. Would have grabbed that as well. Some other sample scans that unfortunately we don't have the full project file for. We're still viewing in Artec Studio, but this is just the finished fusion. This is a smart car. This is captured with 13 Ray scans. Most of those just with the car parked in a parking lot. Those Ray positions evenly distributed around the outside, and then 2 scans from capturing the bottom with this car up on an automotive lift to get all this detail in here. only prep really done was some talc powder sprayed on the wind of the glass, just to, and the headlights to capture those transparent surfaces, just like you would with any other 3D scanning method. So spin this around a little bit here to look at some of those details. Also got the fusion of this airplane. So this was actually really interesting. It was scanned in a museum in Luxembourg. This was hanging from the ceiling of a big open, museum hall. So it was particularly tricky. I think it was 26 scans they had to do to get this captured in this much detail, just because of how far away it was and the kind of angles. There were other things in the way blocking certain parts of it, but this is the result of 26 scans put together. Both these and the car example were aligned with spheres. About a dozen spheres placed around the object was enough to have enough in each individual scan to get these to align together nicely. This is a really great example of how thorough a scan you can get on something big, even when it's far away, suspended from the ceiling where you couldn't reach it otherwise with a handheld scanner. Another fun boat example I have here, maybe not the best example of how to scan with the ray, but I thought this was really neat. So this was, you can see this big circle here was where the ray was set up, sitting on a dock. You can see the shores over here. I captured this whole bridge out to this dock, but scanning this pontoon boat, which was floating in the water. And so both the dock was floating up and down and the boat floating up and down separately produced this really interesting wave effect in the raw data captured by the ray. As it panned from, as it got from one side to the other, you can see it softly was moving up and down relative to the dock. I just thought this was a really neat effect we accidentally captured here. Just to give a sense of scale I know we've talked about 110 meter range, but you can see how long this is. Like here's the two of us sitting around where the ray was set up while that was scanning. It's captured all the way across this bridge, this little boat house here, boat garage, whatever you'd call that, these trees. And even another dock all the way down the shore there.
All right, guys. Now we'll move into a quick Q&A session. You can directly send us questions in the chat, or you can put them so everyone can publicly see them. All right, so we got a couple here. How long does the battery last? Roughly 2 hours. So there's some variables that go into it, but it's roughly 2 hours of continuous scanning. The ray comes with 2 batteries. And to kind of give you an idea, just on from a project standpoint, that full airplane scan you saw earlier was 26 scans, roughly a full day of scanning, and that was 3 full batteries to get from point A to point B. Okay. And what's the accuracy? 0.7 millimeters over a 15-meter distance. That's your ranging error. There's a couple other factors that go into it, especially when you have multiple scans. There's registration error that can come into play as well, depending on how you're registering multiple scans together. So that could be, You can register just by geometry, which is very convenient sometimes. And if you have sufficient geometry variation, then you can still get very accurate registrations. But the most accurate way is using the checkerboard registration. All right. Can you scan in direct sunlight? Yes, you can. So scan inside, outside, complete darkness, or in the middle of summer, a very sunny day. The ray doesn't seem to mind. Can you scan in the rain? No, unfortunately, you cannot. So these are not weatherproof. These are still metrology devices. So you would not want to scan in an extremely humid environment that's precipitating or rain. That would be no good. Can you scan upside down? Yes, you can actually. There are a couple cases where it's really convenient to have the scanner upside down, maybe put into a manhole or into some type of vessel. You absolutely can do that, but that does require an additional calibration that is done at the manufacturer. So if you know you're going to do that, you can let us know on the front end, and we can go and get that calibration done before it's shipped out, or we can have it sent back to the manufacturer to get recalibrated with that additional calibration. You can do some super cool things that way. How does this compare to Faro and Leica? It's a good question because they scan similarly. They're tripod-based LiDAR scanners, but they are still a little bit different. So the Ray is much higher resolution and much lower noise. The Faro Focus and the Leica scanners, they are very popular in the BIM industry. So they're great for scanning huge, large areas, but they don't specialize in the higher detail things. So the Ray is especially good at scanning large objects, boats, earth-moving equipment, buses, things like that, and really engineering applications where you need a mesh to work off of, where you're doing reverse engineering or inspection purposes. One great thing about Artec Studio is that's what it's made for, is to go and export directly into a mesh. So you can start working off of it. Where the other scanners, it's mostly point cloud, and getting to a mesh can be a little challenging. And then the data is a little bit noisier, so you're not going to have that fine detail. One more looks like, can you combine a Leo or EVA scan data with a Ray? Yeah, short answer is yeah. So we're using Artec Studio for all the Artec scanners, whether that's the micro or the Ray or the Leo, Space Spider, all those. So in theory, you could combine any of the Artec scanners together. So yeah, for the Artec Ray, you could take a scan of a large object or a room and then fill in holes, hard to get areas with the EVA or Leo, and then combine those in Artec Studio. Yeah, it's actually a pretty cool and pretty easy process. All right. I don't see any more questions right now. If anybody has any additional questions, you're welcome to reach out to us directly. You can send an email to our just general email, info@digitizedesigns.com email, or reach out to, this is both, me directly or Patrick. It looks like Kyle's on here too. You can reach out to any of us three, and we'll get you information too, or just reach out directly to the website. It looks like, actually, we do have one more question real quick. How about a different brand 3D scanner? I'm not sure what that question means. Maybe, so the Ray is a white labeled surfacer. It's a Model 10 surfacer, which actually was, from surfacers, more expensive by a good bit. Same scanner hardware used in Artec Studio. So you get the advantages of Artec Studio and all the advanced mesh editing. Okay, so clarification on that question, is it compatible with other brands, not just Artec? So yeah, I mean, if you have a software like Geomagic Design X, you can import scans from every scanner ever made all into the Geomagic Design X and combine multiple scans that way. So you could import ray data into Design X, import scans from a ScanTech scanner into Design X and then combine that way as well. That's definitely an option too. All right, looks like that's it. So thank you everybody for jumping on the WebEx today. This is recorded, so we will repost the recording if you want to go back and reference anything. And if you have any questions, just let us know. Thanks, guys.